5.5 section slope. So this section, like it's called slope, we're just going to talk about rate of change and how to calculate the slope. What's a negative slope? What's positive slope? What's a zero slope? And what's an undefined slope? Okay. We're going to end off the chapter with 5.5. I know there's a 5.6, 5.7 that it says on the schedule we're going to go over today, but I think it's better if we treat arithmetic sequence as a different unit than this unit. Because although they are related, linear relations and linear graphs and arithmetic sequences and series, um, I think it'll be better if we just do it off the end. So we'll continue with chapter 6 after today's notes. So today's stuff is not going to be too long. We'll have a shorter day today, and then at the near the end of the semester, we did have those few free days, so we'll stick arithmetic sequences there instead of just talking about, I think we're going to talk about grade 11, 12 content and university stuff. So we can still talk about that, but we can also fit arithmetic sequences in that as well. Okay. All right, so let's move on to the notes for today. So slope, yeah, also known as rate of change. So here's some warm-up. So should be maybe stuff you learned in grade 8 or, yeah, I think grade 8 or 9. So on the grid, plot the points 2, 3, and -1, 5. So these are, again, your x and y, right? So that's your pair of coordinates. What is the vertical distance between these 2 points? So to find the vertical distance, right, we're just looking at the y, right? So without even graphing it, you can see that the y on the first point is 3, the y on the second point is 5. So you can just go 5 minus 3 is 2, so there's a change of 2. Okay. Right, we could have just done this. But we'll graph it, and I'll show you how to do it with the graph too. And by subtracting, that's what you're going to do later on. Yeah, so let's plot the first point, 2, 3. So the x, if it's positive, we're doing 2 units to the right, 1, 2. And it says the y is up 3, so 1, 2, 3. So this is the first point, all right? And then the second point here is -1 and 5. So for the x, -1, and for the y, it's 5 up. So 1, 2, 3, 4, 5. Okay. So we got our 2 points. The second thing you do is you're going to use a ruler. I don't have one right now, but use a ruler. It's really important for this section because, like this is not a proper slope. You can see it's bending a bit here, which is not supposed to. Okay. And that can get you wrong answers because if you're going to read a graph, you might be slightly up a couple units and you'll get the wrong answer. But what is the horizontal distance between the 2 points? So now we'll use a graph to show you how to do that. So horizontal, again, left and right. So we can start from either point, right? So maybe just put a dotted line here to show you that these are the points looking at. So horizontal distance, 1, 2, 3. So 3 units. Either way, you could count 1, 2, 3, because they're asking how far, 3 units. And up and down, again, how we got the 2, 1, 2. You see it lines up like that. Okay. What is the rate of change of the line formed by connecting the 2 pairs? Okay, so they're asking you the rate of change. It's the same thing as saying what is the slope, what is the range of change. So basically, like how, what's the rate of it going down here? Yeah, so to do that, slope is always rise over, let me just move it up, run. All right. So rise just means how far is it going up and down? So the y, right? And then the run is going left and right, so the x. So the change in the y, so you can also write it this way too. So this triangle just means change in, so change in the y over the change in the x, right? So in this case, we did it here. So how much is it changing up and down? So from the first point, I'll move it down. We're going down 1, 2, and this is when the sign matters when you're calculating slope. So 1, 2 down, so it's going to be -2. And we're going to the right, +3. Okay, and there you go. That's the slope. So -2 over 3. All right. Okay. Question 2. What, if any, would you use to describe the steepness of the following line? Okay. So this is the point where we're talking about what is a slope. Is it one's a positive, negative? So here, the one we just did, this is going to be, see how it's a -2 over 3? So this is a negative slope. And by looking at the graph, we know it's negative because it's going downwards, right? So if it's flipped around, if it's going upwards this way, then it would be a positive slope. But what about these cases here? What about when you have a horizontal line and when you have a vertical line like this. Okay, so for the horizontal, so if you calculate this, okay, what if we just did um, let's do change in, let's use a change in sign. So change in y over change in x, right? So how much is it going up and down? How much is it changing from, say, any point on the line here to here? Okay, so any point on the line, it's not really it's not changing. It's not going up and down. So the change is going to be, so say if this is, I don't know, say this is at height 5 on the y-axis, 5, and this is at 5. So 5 minus 5 would give you 0, right? How much is going left and right? It's some number, right? So from here to here or here to here, it's going to be some number. So we'll just pretend like, say this is 0.1 for the x-axis, this is 0.2, so this is 1. Okay, what do you have when the numerator is 0 and the denominator is a number? Right, this is just equal to 0. So horizontal lines are slope 0. All right. What about going vertically? Okay, so we'll do the same kind of thought experiments, I guess. Well, not really just thought, but we're writing it down too. So up and down, again, it's going to be some number, right? That's all is important. So, imagine if this is 0.2, if this is 0.0, okay. So going from 2 to 0, right? If you're going downwards, might be -2 if this is the first point. What about the change in the x, right? Change in the x, left and right. How much is it changing? Okay, these 2 points are not going left and right. They're the same point. So this was 5 for the x, this is 5. They're both at 0.5, so 5 minus 5, again, 0. So in this case, the denominator is 0. So what do you have when you have a numerator being a some number and you have a denominator being 0? This is actually undefined, right? That just means that this is not really possible. So you can kind of think of it as a slope infinity, but the better answer would be like it's undefined. You can't really do this, right? Well, you can do it, but you can't put a number on it. So that's probably a better explanation. So steep, right? Because the rate of change is it's basically like infinity, so you cannot put a number on it. Okay. Okay, good. So number 3, on a grid, on the grid, plot the points 0, 4, and 2, 5. Also note, make sure you have graphing paper because when you're doing your homework, you have these little small grids, so you might as well just do on graphing paper so you can create your own grids on there easy. Join these 2 points. Okay, so we're gonna just write them out. 0, 4 is the first point. Again, the x is the first number, y the second number, 0 here. 1, 2, 0 here for x, and y is 4, right? 1, 2, 3, 4. So this is point. And you should try to label your points. I know it can get messy, but it's helpful for yourself and for somebody looking at it. And the second point is 2, 5. So x is 2, 1, 2, y is 5. So 1, 2, 3, 4, 5 up here. Right. So let's label this up here. 2, 5. Okay. Name another point that would continue to make a straight line with these other 2 points. Okay. One way to do it is if you want to find additional points along the slope, is to just extend the slope out, right? So you can see the slope here is like this, right? Again, this is another reason why a ruler is important, and you can see if I put an arrow here because it's going to keep going the slope. We extend it out, right? So if I go down like this, and so it's going to go, I think another point would be here. It would be a lot better if I used a ruler. I just had to make sure I cross certain points. Okay, so when you're extending it out based off the slope with the ruler, now you can just find a couple points. So, and when you're choosing your points, you could choose anything on the line, on the slope. You could choose here, or choose here, or choose here, but it's better to choose ones that intersect at the cross because it's more precise. That's at this point. If you choose something that's like in the middle here, how do you know what the decimal is? Is it 5? Is this y is 3 point, over here 3.1, 3.15, 3.16, right? So there's the point, and now we just calculate. So here it's the x is -1, -2, right? And the y is 1, 2, 3. So -2 for x, we got a point, and we'll choose another point along the cross right here. And then that is 1, 2, 3, 4, -4 for y, and up 1, 2. Okay, there we go. Okay. Explain how you chose your point, and that's kind of what we just explained, but first step is make line or make slope longer, like extend it. Okay, and then 2, well, make slope longer and extend it, then just find the point. Another way you could do it is follow the pattern. Okay, I'll talk about that right now. So the pattern here from these 2 points that we had originally, you go down 1, left 2, 1, 2, then down 1, left 2, down 1, left 2. Okay, there you go. So if you find that pattern, and slopes, they all have a pattern like that, which kind of ties into arithmetic sequences, which we'll go over again at the end of the semester. So left 2, down 1. Okay. All right, so let's move on to the next page. Okay, so page 2 of the notes. Again, definition of slope. Slope is the steepness of an incline or the ratio of rise to the run for a line, and we can use this by using 2 points on the line. So again, this is like the first point. The first point has its points x1, y1, right? We just label it to keep organized, the ones. And the second point would be x2, y2. So yeah, and this is the same thing as rise over run. And then again, I mentioned before, the change in y, the triangle stands for change in, and the change in x, which is equal to rise over run. Okay, so that's all you really need to know for when you're calculating slope. So let's just jump into these examples. There's a lot of examples to go over, so I'm going to try to be quick. Or we don't need to do every single one here because they're exactly the same way. We'll do a few of them. Okay, so let's do. And again, if I'll do I'll do the first few, and then if you want to look at the answers for the last couple, or you're doing your own notes, I want to complete it. Just I'll have it posted on our class notebook. Okay, determine the slope of each line. We have line segments AB here. So again, how do you find slope? Is we could just say rise over run. Okay. So how much does slope AB rise? Just go from and either one, doesn't really matter which way you start. Okay. So here, well, it doesn't matter, but you just make sure of the note. So if you're starting from B and you're going downwards, right? So 1, 2. So basically, oh yeah, let's just start from here. So 1, 2. And then going left and right, so the rise is 2, is 1, 2, 3, 4, 5, 6. So 2 over 6. Okay. And the last thing you want to do is always simplify your answers. So 1 over 3. Okay. And just check, it's going upwards, right? So upwards, it's going to be positive, so it is positive slope, and that's pretty much it. Okay, CD. So you can tell this is a negative slope. Okay, when you're starting from the first point, if you want to do the math, well, we'll do the math on the next section, but you're going from the first point to the second point, we're going downwards. So the y here is negative, right? 1, 2, 3. Is that 3? Yeah, 3. So this is going to be -3 for the y. And for the x, 1, 2, 3, 4, 5. Okay. And I wrote it the wrong section. -3 over 5. Okay, hopefully you can get that. Okay, so EF. So EF is the vertical one. Okay, and again, remember what vertical slope is? It's going to be always undefined, but we can try to calculate it. Here we have the y going from E to F is 1, 2, 3, 4. And a change in x is not changing left and right, so it's 0, which is equal to, that's just like the undefined sign, right? Okay. GH, okay, we already know there's a flat slope. Remember the horizontal flat slope? You should already, right when you see this, you should know it's 0, but we'll just calculate it. So going rise and run up and down, it's not changing, so it's 0. Going left and right is 1, 2, 3, 4, 5, right? So this is 0. Okay, good. All right, so example 2. Let's tilt this over a bit. So use the slope formula. Okay, y2 minus y1, x2 minus x1. So this is just change in y over the change in x. Whenever you do the change in something, in math or physics or whatnot, you always do the final point minus the first point, right? So that's why 2 is before the 1. So final minus initial. Final point minus initial point. Okay? So like the second point minus the first point. Second point for the x minus the first point of the x. Okay? Determine the slope of the line passing through each pair of points. Okay, so they want us to use the equation. You could have graphed this and use the ruler. So the equation, again, I'll write it out for the first one. Might need some room. So m, and m is usually the variable people use to as slope. So m is the slope. So what's the formula again? y2 minus y1, x2 minus x1. So again, the first point is the first point. So this is x, right? x1, and this is the y, so y1, right? And then for the second point, x2, y2, right? Okay, so now we just plug it in. So what is y2? y2 is 4. So 4 minus. What is y1? y1 is negative 1. So just be careful of the signs here. Over. What is x2? x2 is 3. Minus x1. What is x1? It's just 2. So you can put 2 there. Okay. So 4 minus minus 1, which is then it's plus. So it's 4 plus 1 is 5. And 3 minus 2 is going to give you the 1. Okay, so 5 over 1 is the same thing as 5, right? So m, or the slope, is 5. Okay, we'll do another one here. So I'll just put a line here so it's fine. Okay, so again, label them x1, y1, x2, y2. Okay, and the formula, I won't write the formula here because there's not much room here, is going to be y1 is 7. So let's put m equals 7 minus y2. Oh, sorry. I already did it wrong. y2 minus y1. And y2 is actually 7 too, so that would have been okay. y2 is 7. So 7, all right, minus y1, which is also 7, okay, over x2, which is negative 3, minus x1, which is 0. So minus 0. Okay. So 7 minus 7 is 0. So 0 over negative 3 minus 0, which is negative 3. So 0 over any number is going to be 0. So this slope is 0. So you should know, if I asked you, how does this slope look like on a graph? Automatically you should know this is a horizontal line, right? A flat line. Positive slope, you know it's going to be going upwards, right? Okay, so you do the same ones, the same sort of idea for these two as well. And if you do this in your head, this is going to be 11 over 5. And 11 over 5, again, you know, it's a positive slope, so it's going upwards. Then this is what, roughly like 2.2, I think, close to that. So you know that this slope isn't as steep as this one. So the higher the number, the more steep it's going to be, or quicker rate of change, right? If you do this one out, you'll get negative 3 over 0. And again, any number over 0 is undefined, right? So that means this one is going to be, and just by knowing this, you should know it's going to be a straight vertical up and down. Okay, last part here. So example 3, graph each line given the points on the slope, on the line and its slope. Okay, so here they only give us 1 point, right? But they also give us a slope, which is 3. Okay, so 3 is just telling you the pattern or how fast it's changing. So 3 is also the same thing as 3 over 1. So this is the same thing as, this just means rise is 3. So every time it's going up or down 3, it's moving left or right 1. And you know it's a positive slope, so you know it's going to go some in the positive direction. So first thing, you're going to just plot the point 4, 5. So x is 4, so 1, 2, 3, 4, and y is 5. So 1, 2, 3, 4, 5. Okay, right here, and I'll just label this. Well, I'll label it right after because I want to see how the line goes. So again, it's a positive slope. That means it's going to go upward. So I can go 1, 2, 3 up, and 1 to the right. And I could do that again. Well, if I had more points, 1, 2, 3, roughly would be up here somewhere. And then this one, I can go the opposite direction. So up, if it's positive, you're going up, then right, up and right. If it's negative, you're going down. So 1, 2, 3, and left. Okay. Down, 1, 2, 3, and left. So once you have like at least 3 points, you could do 3 or 4, 5 if you want to do extra safe, but 3 should be enough. I just did some extra. Now we can just use a ruler, not like this. Okay, whoa. Okay, and again, that's going to be your line there. Okay, and again, this is an ugly line. Use a ruler. Okay, so next thing is, let's do the next example. Okay, so again, start with a point, -2 and 6. So 1, 2, -2, and then, oops, I shouldn't have put a point there. -1, 2, and 6 up. So 1, 2, 3, 4, 5, 6. This is actually the point. Yeah, and I'm using a pen too. So I'm using a pen just so you can see easier, but always use a pencil because I need to erase this one. Okay, anyways, what's the slope? It's 1/2, right? So rise over run. Remember, this is rise, this is run. That means we're going up 1, and it's positive, so we're still going the same direction, right? Positive direction, so 1 up, 2 over, 1, 2. 1 up, 2 over. Okay, there we go. So we got 3 points. And now we can just connect them. You should, if you have a ruler, you can really extend it out further, but I'm just gonna like that. So you can see also that this is a smaller value, 1/2 compared to 3. So 3 is going to be a lot steeper than the half slope. Okay. Okay, last one. What about this? You can note that it's negative. So how's that going to look? So you know it's going to go downwards, right? Because it's negative. Again, any number is over 1, so -2 over 1. And this is rise over run. So start at the point that they gave you first. So -5, so down. 1, 2, oh, sorry, x first, because this is x, then y. So 1, 2, 3, 4, 5, and then -3. 1, 2, 3. Okay. And now you can go rise over run. So it's going down to, because it's negative, 1, 2, and 1 to the right. Okay. Down to 1, 2, and 1 to the right. Okay. And let's do a couple more. Or you can go the opposite direction. You can go up to 1, 2, and 1 to the left. Up to 1, 2, and 1 to the left. So remember, I know it's going to go, I did the opposite of what I did before because it's negative. So it's up and left, down and right, whereas the positive slope is up and right, and down and left, and down and left. Okay. So once you get a few points, you can use a ruler. Well, that one's not too bad. Okay, and then do that, and you should also probably label your initial point, which is over here, I believe. Negative, what was the initial point? -5. 1, 2, 3, 4, 5, and down 3, 3. So this was my initial point, -5 and 3. Okay, and that's about it. So for homework, is this going to be, you're going to do some chapter 5 review questions on 5.1, 5.2, 5.3, and some 5.5 work as well. Okay.